How's it going, everybody? We're going to be looking at the introductory to trigonometry right here. We're going to be looking at the three main trig ratios: sine, cosine, and tangent. Now, when you're looking at these ratios for the first time, it might be a little bit difficult, but don't worry. I'm going to just focus on the basics. When we're writing trig ratios, we are looking for a fraction using trigonometry, and the main thing is you need to be using a right triangle. Now, the main thing when it comes to this part is we want to identify the hypotenuse, the opposite, and the adjacent sides on a right triangle. The hypotenuse is always going to be the biggest side, and in this case, across the 90 degrees here. So this is our hypotenuse, which just means this is the largest side. Now, for the opposite and adjacent piece, is determined by where the angle of reference is located at. In this case, I'm going to make our angle of reference here. And the angle of reference is always going to be opposite. It's going to be facing the opposite side. So it's always in the opposite. If the angle of reference is on the left, the opposite side will be on the right. If the angle of reference was up here, then it would be towards the bottom. And this is the adjacent. Now, a trig ratio is used to find the measurement of a missing side, but for today, we'll just be writing the trig ratios. So if I look at this first example here, I'm going to make my angle of reference, my theta, on this corner here. My hypotenuse, since it's in this box, it's going to be over here, and I'm going to give some numbers for reference. So I'm going to say this is 5, 4, 3. In this case, 5 is our hypotenuse, so I'm just going to call this h. Our angle of reference is on the right side, so this one here is our opposite side. And then the 3 is going to be the adjacent side to the angle here. To write all three trig ratios, sine theta, cosine theta, and tangent theta, sine says it's opposite over hypotenuse, so I'm looking for my O over h. In this case, the opposite is 4 over 5. For cosine, AH, in this case, 3 over 5. And for tan, we need the opposite over the adjacent. So therefore, we need O over A, which in this case is 4 over 3. And that's our trig ratios right here for this first example. Now, sometimes you will be given the symbol theta, and at times you will receive, just to change my picture up a little bit, still dealing with the 90-degree angle. Instead of theta, you might get an x, but it is the same thing. If I use the number 10, 8, and 6, my 10 here will be the hypotenuse. This is my angle of reference, so 8 is my opposite, and 6 would be adjacent. To write my trig ratios again, sine, cosine, and tangent. Sine again uses OH, 8 over 10. And if I reduce, this is 4 over 5. Cosine would be AH, 6 over 10. And reduced to 3 over 5. Tangent here is going to be O over 8, so 8 over 6, which reduces down to 4 over 3.